Hey again, everybody. Mr. Pike again, coming to you live. Well, not really live, pre-recorded. In this video, we're going to be doing section 1.3, which is all about graphing systems of equations and systems of inequalities. So mainly, we're going to be looking at graphing systems of inequalities, because I think that is mainly what you're going to be looking at. So just jumping right into it. Remember, you guys have y equals mx plus b form. Do not forget from me, please. If you solve for the y, the m is the slope, and slope represents rise over run. So how far we go up and down over how far we move left and right. The b is the y-intercept. So if we plug in 0 for x, this part essentially goes away, and we are just left with what y equals when x is 0. All right, so as we are doing that, I'm going to solve for y in most of these things, because it's going to help us graph. So for this first one, we have y is less than or equal to x. So our simplest one, so if I put in, there is no other number. Oh, sorry. All right. But there is no other number, so there's not like a plus or minus like there is down below. Like this one, I can tell the y-intercept is -1. This one, since I don't have a number, remember 0 represents nothing, so it's going to cross the y-axis at 0. Don't forget the y-axis is the one going up and down. Right? So now if I have a number in front of x, which is just I have one of them, that means I go up 1 over 1, up 1 over 1, and then I can draw the best line that I possibly can. Now notice, since it is less than or equal to, what that means is I actually draw a solid line, because we could actually be right on that line and it would still be fine. And if I want to be less than it, I pick a point on the line. Numbers that are less than where I'm at right now are below, so I could be anywhere underneath it for that problem. So now for this other equation, y is greater than or equal to 3x minus 1. So my y-intercept is going to be -1. And then my slope is up 3 over 1, since that looks like rise over run to be 3 over 1. So I'm going to go up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And I have greater than or equal to, so I'll draw a solid line. And now if I pick a point somewhere on this line, if I am greater than or equal to it, I want to be somewhere above, which means I want to be on this side of the line together. So now what the solution for this actually is where these two parts meet. So these two parts meet in kind of this area right here. So this would be the only shaded section of my entire graph altogether. This is where the points could be such that both of these are true. So one of my points that would be in the solution set is what it's called, is I could have like -4, -4. That would work for both equations. So we have -4, -4, it's right there on the line. I could even have -4, -5, because if I go to -4, -5, it's in my shaded region, so therefore it is a point that's actually possible with these two equations. All right, look at number 14. So notice about number 14 is I don't have the y solved for yet. So what I need to do in this one is I just need to move over the 2x. So I'll subtract the 2x such that y is greater than -2x plus 3. And in my other equation, if I solve for y, if I subtract the x, I'll have -y is less than -x plus 2. So now I still need to get the y by itself. So what I need to do is I need to divide my entire equation by -1. Please, 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 do not forget, is if you multiply or divide your entire equation by a negative number, if you multiply or divide an inequality by a negative number, you have to change the direction the sign is facing. So this would be y is greater than x minus 2. Those are the two equations that I'm going to graph. All right, graph the blue one in blue. So I have +3, so my y-intercept is at 3. I have -2 over 1, so it's down 2 over 1, down 2 over 1, down 2 over 1, so on and so forth. So now, the other thing I notice is it is just y is greater than. It's not or equal to. So if it's just greater than, the way I signify that is we draw a dashed line, because that dashed line shows it's like really, really close to that line. We can be as close as we possibly want, but we can't actually be right on the line, so I'm not shading it in. Now if it says y is greater than, if I pick a point, greater than would be above, so now I would shade anything over there. That's where I'm going to look for one of my solutions. So now for the other line, y is greater than x minus 2, I have -2. My slope is up 1 over 1, so up 1 over 1. And again, it's just greater than, so it's a dashed line. It is not equal to. So a dashed line for that one. And it says y is greater than, so if I pick a point on the line, it would be above it. And now the part where they meet is just this region up here. So I will shade in only that region right there. That is the only place that my solutions are. So now the thing for this one, I know in the last one I said if I was on the point, I could have that, and that's fine. It's not a problem. But on this one, if I am on the line, since that line is shaded, dashed, I cannot be straight on the line. So if I am not equal to, notice I am just greater than and just greater than, I'm not equal to that line, I cannot have a point in my solution set on that line. All right, moving on again. So again, notice we don't have this solved for y. So what I need to do is I need to subtract the x such that I would have 3y is less than or equal to -x plus 9. And then I will divide by 3. So I have y is less than or equal to -1/3 x plus 9 divided by 3 is 3. So I will have up 3, and then my slope is down 1 over 3, down 1 over 3. Draw the best line we can, and I have less than or equal to. So I have the equal to makes that a straight line, and the less than means it could be somewhere down there. Yeah. All right. Now the other equation, I need to subtract the 2x over, so -y is greater than -2x plus 1. And then I need to divide by that -1. So again, whenever you divide or multiply by a negative number with an inequality, you need to change the direction the sign is going. All right, so now I have y is less than 2x minus 1, so I'm crossing at -1. My slope is up 2 over 1, so 1, 2 over 1, 1, 2 over 1. And I am just less than, I'm not equal to, so I need to make that a dashed or a dotted line, either way you call it. Less than, so I would be below the line. And the only part that I really want to shade is the part where they both meet, which would be the part right down here. Get out of the way. There we go. Part right down there. All right, getting close. You guys are doing good. So now here, this one's a little bit different because I notice I don't have a y value. I just have an x. So if I divide by -2, then I will have x is greater than 1. Remember, I switched the sign because I'm dividing by -2. So if I have x is greater than 1, x is 1 right here. So anywhere over here, and for x to be greater than 1, it would be somewhere over here where the x values are greater than 1. Now this other equation, I have what I'm used to seeing, y is less than x plus 1, so I'm crossing at 1. My slope is 1 also, so up 1 over 1. And I am less than that, so I'm not equal to. I'll draw a dashed line, so somewhere below that, and the place where these two things meet is anywhere in here. Here! And there we go. All right, moving on. You guys are doing good. Don't forget, you guys can pause the video, you can rewind, you can rewatch. Please, please, please use all of that to your advantage. You're in the age of technology. I didn't have technology when I was younger. The coolest phone we had was like a Razor, a flip phone. I don't know if you've ever seen a flip phone. All right, we have y is less than or equal to 3. So the y value of 3 is right here. Y is always 3 along this line. And if I am less than or equal to, that's why I'm going ahead and drawing a solid line, less than or equal to would be somewhere down there. Now I have the other part, y is greater than 4x minus 3, so I'm crossing at -3. Then I'm going up 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And there's my good enough line. Since I am just greater than, I'm going to have a dashed line. So now this one's a little bit difficult, especially when they're kind of going like up and down. It's kind of hard to imagine sometimes. But if I pick a point and I think about where my y value is greater, because that's what it says, y is greater, they would be somewhere up here. So that tells me that I'm graphing on this side of the line. I'm shading. And these two areas meet, these two regions meet right in there. So it's any of those points that would be okay as solutions for both of these altogether. All right, I'm going to do one more together, and then we're going to go to one more concept in this video. You guys are doing good. So I have y is greater than -2. Y is -2 right here. And notice it says greater than or equal to, so that's why I went ahead and made it a solid line. So I'm greater than somewhere up here. Now this other equation, dang, I got to solve for y, but that's all right. It's just moving the 3x over. Don't complain, just do it. All right, so y is less than or equal to -3x plus 2. So I have a y-intercept of 2. So I will move down 3 over 1 for my slope, down 3 over 1. And I am less than or equal to, so I know I'm going to make this a solid line, best I can. Solid line all the way throughout. So now y is less than. So if I pick a point, where are my y values less than this point? Well, they'd be down here, so I'm shading on this side of the line. All right, in my feasible region, the region that works, the shaded region where they both work would be right in here. So that is really only region that I'm looking at for this to be shaded where any of my solutions could possibly be. All right, I'm going to take a second. Actually took 3 hours. No, I'm just kidding. This is like 2 minutes. All right, so with these, notice we have multiple equations. These are what we call linear programming is what it's called. Why it's called linear programming, I'm not exactly sure, but it's just a multiple linear equation program. We can do it with quadratics. We can really do it with any types of equations that we want. Exponentials, which you'll learn more about. Logarithms, which you'll learn more about. You probably never even heard that word before. If you have, then you're going to do really well. It's just multiple equations. That's really all it is. And then we'll determine which of the following points are solutions. You'll kind of see how that works. Just like I was talking in the earlier section of this, we're just going to be looking to see that they're in the shaded region. So just go through these one at a time. Y is greater than x minus 4. So I'm going to have an y-intercept of -4. My slope is up 1 over 1, up 1 over 1. So I'm going to be dashed line. And I'm just putting more to be more accurate, so that way when we do and determine which one are actually solutions, it'll be a little bit easier to tell. So I'm going to treat this as my dashed line, and I want to be somewhere above it, so somewhere up there. Y is greater than. Now my next one, y is less than or equal to 3. So I have y is less than or equal to, so equal to tells me solid line right there. And if I am below, I'm somewhere in here. So it's looking like I'm going to be somewhere in there maybe. My last part, x is greater than -1. So if x is greater than -1, I have a dashed line when x is -1. And I want to be greater than -1. So it looks like the only part that actually works is kind of this triangular area that I created right here. Right, so this is the only part that we have any solutions for all three of these, that any points would work for all three of those equations. So determine which of the following points are solutions. 0, 4. Well, 0, 4 is way up here. It's right there. Right? X is 0, y is 4. So no, that is not a solution. 1, -1. If I go over 1, down 1, that looks like it's in the solution set. So yeah, I'm going to say that's a solution. And then if I go to 2, 3, over 2, up 3, so here's the tricky part, is it's on y equals 3. I was telling you guys, if it's on the line, that actually is possible, as long as we are equal to that line. So that's cool there. So we have over 2, up 3, so that point is fine. -1, -5, so I have -1, oh, let's go the other way, and -5. So notice that's on 2 dashed lines, so that's not actually a part of our solution set. So that does not work. And then if I go over to 4, up 3, again, that's on my y equals line. I was equal to there, so I should be good to go. So I really only have those few. All right, looking at the next one. All right, with this one, again, it's just systems of inequalities, essentially. That's what we're doing linear programming with. So I have, just go one at a time. So y is less than 2/3 x minus 3. So I'm going to have a y-intercept of -3. I have rise over run. My slope is up 2 over 3, so I'll put a point, then put another point, up 2 over 3. And since I'm less than, it is a dashed line. So just make the best line you possibly can. And if you read this, y is less than, so I'm here, y is less than, so y is below all the way throughout that line. Going to the next line, y is less than -1/3 x plus 4. So I have a y-intercept of 4. So I have y-intercept of 4, and then I have down 1 over 3. down 1 over 3, down 1 over 3 as my line. I am less than or equal to, so I will draw a solid line all the way throughout. Okay, and then my last equation, x is greater than or equal to negative 3. So x is greater than or equal to negative 3. So I have negative 3 right here. That's not where negative 3 is. I'm lying. I'm just kidding. That's negative 5. Don't do that. So I have negative 3. And x is greater than or equal to, so I'm somewhere over here. And with my other one, I'm sorry I didn't get my pink one in there. I have y is less than or equal to that one, so less than or equal to there. So it's only where these three things meet that I want to actually shade in, and it would be anywhere in here. And draw a monkey in there just for good luck. All right, please, as always, let me know what questions you guys have. I'm here for you guys. We'll talk to you soon. Bye.